Greetings, everyone, and welcome to our dedicated YouTube channel, the Confidence Scientist STEM Network. Today, I'm coming to take you through a more fascinating emerging forensic science topic in nanotechnology in forensic science. So, first of all, I am Lucy Fuseini, a BSc Forensic Science student at the University for Development Studies, and I'm the one who is going to take you through this fascinating topic, which is nanotechnology and forensic science. So this is the content of my presentation, and I would like to encourage you to stay tuned as I take you through these contents of my presentation. But please don't forget to like, share, and comment as we move on. So I want to ask, what at all is nanotechnology? So when we talk about nanotechnology actually implies you manipulating, studying, and then applying functional materials and systems through a control of matter at a nanometer scale level. So a nanostructure is actually any matter ranging from 1 nanometer to 100 nanometers. And then the concept behind this nanotechnology was actually coined by a man named Richard Feynman in 1980. So what role do nanotechnology plays in forensic science? So there's actually a new emerging field whereby nanotechnology is actually integrated in its activities. So this field is actually known as forensic nanotechnology. So these areas of which we actually employ nanotechnology includes in drug screening, explosive detection, latent frame detection, person document analysis, among many others in forensic science. So why do forensic scientists actually choose nanotechnology in their activities? This is because nanotechnology has invaluable assistance to forensic scientists due to its higher limits than the other limits that other instruments that we know. They also allow for identification and analysis of nanoscale samples that were previously impossible to forensic scientists. So today we are going to dive into the various roles and then that nanotechnology plays in some areas in forensic science. So the first area that I'm going to take you through is actually DNA analysis. So when it comes to DNA analysis, magnetic nanoparticles can be used to successfully extract DNA from various biological samples, including hair, blood, and then saliva. We can also use the gold nanoparticles to actually enhance efficiency when you are doing PCR. And then after the PCR analysis, which is post-PCR, we can use a microfluidic system to actually quantify the DNA samples that we have because it has short examination time, less contaminable, and it has the ability to be used at the crime scene. And then we can also talk about nanotechnology in fingerprint examination. So when dealing with fingerprint examination, we can apply these particles to the traditional methods that we know to actually enhance fingerprints. And then these new nano particles and nanopowders can actually now augment contrast, improve selectivity, and then enhance the identification of latent fingerprints on various surfaces that you and I know. So let's dive into it. So we can use the nanoparticle powder such as zinc combined with silver oxide with small particle reagent to actually improve latent fingerprints. And then we can use other nanoparticles that actually interact and then have electrical conductivity and they fluoresce with these fingerprint residues, such as the gold nanoparticles, zinc nanoparticles, and then cadmium nanoparticles, of which will help us to enhance our fingerprint that we are dealing with. And then we can also use the quantum dot, which is a semiconductor nanoparticle. What you say is more fascinating? It's fascinating. That will flourish under ultraviolet light, highlighting our fingerprints that were usually unable to be highlighted with the old methods that we use. And then we can also talk about nanotechnology in toxicology. So in toxicology, what nanotechnology actually does is it helps us to actually detect and then quantify toxic substances that are present in our various biological samples, such as hair, saliva, among many others. And then we can use the antibody functionalized magnetic nanoparticles to actually identify drugs in their metabolites, drugs such as amphetamine, such as cocaine, such as codeine, can use these nanoparticles and nanotechnology to actually identify their metabolites. And then we can also use a quick method to actually identify pharmaceuticals in human urine samples specifically by combining the gold nanorods that we have and then the dynamic surface enhanced Raman spectroscopy with the support vector machine system algorithm as well. And then we can also talk about nanotechnology in areas such as question documents examination, whereby when you add these nano particles to the questioned documents, it can help us to actually provide helpful information such as any adulteration, obliteration, erasures in the documents. And then we can use the AFM, which is the best tool for these kind of things. And then its working principle is based on one, it helps us in scanning the paper. Afterwards, it will examine the ink trails and then it will reveal the sequence of the surface morphology. That's the form of the question document that we are dealing with. And then we can also use the image inks and visible dyes on the banknotes and distributed movement to actually help us to identify a question document. So we can combine the gold nanoparticles with solvents and LDIMS methods for this examination as well. And then we can talk without talking about nanotechnology in firearms and then identification. So in gunshot residue, we can actually help us to identify lead, barium, antimony, which are the components of the gunshot residue. You can use the electrochemical sensors such as the gold platinum to actually, analyze the gunshot residue. After that, you don't end it. You have to use the X-ray spectroscopy to actually determine their elemental composition as well. So these are some real-world application of nanotechnology. This is a particular case whereby a burglary incident, we use nanotechnology to actually identify fingerprint left by vaporizer on the paper of which the old methods failed, and then it later led to the arrest of the suspects. And then we can use it, we also use it to actually determine illegal substances in a narcotic trafficking enterprise. This particular case, it was the gold nanoparticle that was employed. And then we cannot talk much without talking about the issues associated with the use of nanotechnology, such as the health and safety risks, its bioaccumulative nature in organisms, plants, and animals, which will actually endanger our ecosystem. And then it's actually expensive, making underdeveloped and developing countries not being able to, implement it in their various activities that they do. And it has privacy concerns when it comes to its use, and then legal framework issues as to how it is being used, as to how the evidence are collected and analyzed with these nanotechnologies. And then what are the future of nanotechnology? I think with this application of nanotechnology in forensic science, it stands poised to revolutionize forensic science, affording forensic experts unparalleled tools and insights to elevate crime solving and enhance our public safety, making our society safe as well. So I'll encourage all of us to grab this opportunity to use nanotechnology in our dealings. These are the references that you can dive into for more insights on nanotechnology in forensic science. And I would like to encourage each and every one of you watching this video to like, comment, and share. And then if you have any question, you can drop it down there at the comment section. Stay tuned for more updates from UDS Forensic Science Department at large. Thank you for watching this video. Again, you can dive into these references for your perusal as well.